Let us look at some of the things that we will be handling in data processing. Number one, we look at data quality assessment. Number two is data cleaning. Number three is data transformation. And number four is data reduction. So what is data quality assessment? Data quality assessment is basically we'll be looking at the anomalies and any problem that we should look out for in a data set. Such anomalies include, for example, mismatched data types. Think of it this way. You have data that is in currencies. One currency is in dollars, the other currency is in Kenya shillings. It is proper to convert all the currencies into a single format, if it is Kenyan currency or if it is dollars. Another anomaly to look out for is the infamous data outliers. Outliers can have a huge impact on data analysis results. For example, if you are averaging test scores for a class and one student didn't respond to any question, so they got a 0, that 0 will affect the general result. And one last anomaly that I will point out is missing data. Take a look for missing data fields, blank spaces in text, or unanswered survey questions. This could be due to human error or incomplete data. To take care of missing data, you'll have to perform data cleaning. This takes us to the next point. What is data cleaning? Data cleaning is the process of adding missing data and correcting, repairing, or removing incorrect or irrelevant data from a data set. Data cleaning is the most important step of pre-processing because it ensures that your data is ready to go for its downstream needs. Data cleaning will correct all the inconsistent data you uncovered in your data quality assessment. Depending on the kind of data you're working with, there are a number of possible cleaners you'll need to run your data through. We look at missing data. There are a number of ways to correct for missing data, but the two most common ones are you ignore the tuples and manually fill in missing data. To ignore the tuples, this is what we're talking about. A tuple is an ordered list or a sequence of numbers or entities. If multiple values are missing within tuples, you may simply discard the tuples with that missing information. This is only recommended for large datasets when a few ignored tuples won't really harm any further analysis. And you can also manually fill in missing data. This can be tedious, but is definitely necessary, especially when maybe the dataset is small. Another thing to look out for in data cleaning is noisy data. Data cleaning can fix noisy data. This data includes unnecessary data points, irrelevant data, and data that's more difficult to group together. We look at in binning, regression, and clustering. Binning sorts data of a wide dataset into smaller groups of more similar data. Regression is used to decide which variables will actually apply to your analysis. Regression analysis is used to smooth large amounts of data. This will help you get a handle on your data so you are not overburdened with unnecessary data. Clustering algorithms are used to properly group data so that it can be analyzed with like data. They're generally used in unsupervised learning when not a lot is known about the relationship between your data. The next place that our data will go to is data transformation. With data cleaning, we have already begun to modify our data. But data transformation will begin the process of turning the data into the proper formats. So you'll need for analysis and any other process. In data transformation, we will look at 5 things. Number 1 is aggregation. Data aggregation combines all of your data together in a uniform format. Number 2 is normalization. Normalization scales your data into a regularized range so that you can compare it more accurately. For example, if you are comparing employee loss or gain with a number of companies, some with just a dozen employees and some with 200 plus employees, you'll have to scale them within a specified range like 1.0 to 1, 0 to 1, and so on. That is normalization. The next thing we look at in data transformation is feature selection. Feature selection is the process of deciding which variables are most important to your analysis. These features will be used to train models. It's important to remember that the more features you choose to use, the longer the training process, and sometimes the less accurate your results. The next thing that I will just point out is discretization and concept hierarchy generation. Discretization pulls data into smaller intervals. It's somewhat similar to binning, but usually happens after data has been cleaned. Concept hierarchy generation. Concept hierarchy can add a hierarchy within and between your features that wasn't present in the original data. And finally, we look at data reduction. The more data you're working with, the harder it will be to analyze it, even affecting cleaning and transforming it. Depending on your task at hand, you may actually have more data than you need. Especially when working with text analysis, much of regular human speech is superfluous or irrelevant to the needs of the researcher. It will also help identify the most important features to the process at hand. This is data reduction. So in data reduction, we can do attribute selection. Similar to discretization, attribute selection can fit your data into smaller pools. Another thing you can do in data reduction is numerosity reduction. This will help with data storage and transmission. You can use a regression model, for example, to use only the data and variables that are relevant to your analysis. And finally is dimensionality reduction. This again reduces the amount of data you use to help facilitate analysis and downstream processes. Later on, we look at things like k nearest neighbors. This is an example of dimensionality reduction. It uses a pattern recognition to combine similar data and make it more manageable. Thank you, and let's go to the next process.